Hello there! I just recently made a video about Chainer that you can use it to upscale your images with a model, and today I wanted to show you how you can actually train such a model yourself, your own model. And for this we are using a model I just recently released, or not using that model, but we're using that process I made. So you can see it's an anime model, so meant for anime, and it will enlarge it or upscale it to two times its size. And you can see some examples here. How will it improve? Another example here. So yeah, so we will basically make this model, or I will show you how you can train this model yourself. So we need different things for this. First, so if I'm showing you how to train it locally, you will need a PC, of course, an NVIDIA graphics card, and a Linux operating system. This is because the code I will show you, and most of these codes have been tested for Linux. There are also different methods. You can also train such a model online with Colab or Kaggle or Runpod, and then your operating system wouldn't matter. But I'm showing you right now how to train it locally, and after I could maybe show real quick these other solutions. But the first thing we need is training code. Now there's different code bases you can use for this. There's trainer, there is trainer Redux, there is sudo's Colab trainer, which would be an example of, you're training it on the Google infrastructure, that model. And the one I will be using or showing or have been using is Real-ESRGAN code repo. So you can simply click on code, download the zip, open it up, extract that one, extract here, and then you should see a folder structure like this. Extract it to the hard drive, where you want to use all of this, because this will take disk space. So you have the code files now. What you will need now is to install all the dependencies on your system for this to work. And you will see down here, there are dependencies, Python, PyTorch, and basic SR actually has its own dependencies. I'm going to open it up real quick. Basic SR GitHub. And this is a software that the other one is built upon, and this one has its own dependencies. In the installation section, you can see the things I said again, an NVIDIA GPU, Linux, but then we need Python. So we can, test this out, open a terminal on your Linux, or, search for terminal, open this terminal, and it might like a little different, but it's the same. So you can type in Python 3 and then run it, and you can see here it says I have Python actually running 3.8, so it needs 3.7 or higher. So I'm good here. If you get an output like this, you're good and you fulfilled this dependency already. Otherwise, you go to Python, the downloads page, you see, and then you can download a version of Python. So for me, it would be 3.8. Click download and install it. Once you have this dependency, we can go to the next one. That's PyTorch. You can open it up, click on install, and then choose the settings you need. So stable, Linux, pip, Python, CUDA 11.7. Then there is a text down here. You simply select it, copy, open the terminal again, and paste this, and then press enter. And I don't need to do it because I have it installed, but if you press enter now, you will install all these dependencies for you. Once you have that, you will need the last dependency on the list here. For basic SR, that's CUDA. We can open it up and then choose our operating system, our CPU, our structure, architecture, AMD. Ubuntu is what I'm using. And then the version, you can always check if you're unsure. It's 20.4, so choose 20.4. A Debian installation file, Debian network because I don't have problems with internet. And then you simply copy each of these commands and paste it, into the terminal and let it run, and copy the next one, paste it into the terminal, let it run, sometimes with your password. And after you went through all of these installation commands, you have the dependencies for basic SR. Now, Real-ESRGAN will have its own pip dependencies again that we need to install. So we go into the folder where you extracted that code structure and open this in a terminal again. So make sure that this path is correct. And then you do the same thing again. So you copy each of this command, paste it, press enter, let it run. Do the next one, copy it, paste it, press enter, do the next one. And after you've done this, you have all the dependencies installed that you will need. Now, after we have the code base, we will need a dataset. So you can, for example, in the Discord, find datasets released. And for this example, we're going to use the HFA2K dataset for anime single image super resolution. You can see that's anime images. You can simply click on download, start this as a standard download, then extract it again. I already did this. I have it on my hard drive in datasets, and then you will see it's images or image crops. These are the images we will use for training our model. And how this works, basically, if I draw this real quick, is we have our high resolution image. So these are these images. So this would be, for example, this image here. And now the model needs a low resolution image. So the same image but smaller. So if we do a 2x model, so it doubles it, so then this would need to be half the size of this. And then we would do this for every single image there is, and then the model would learn, what the input is and what the expected output is, and then learn from this. Now we could add additional, it's called degradations. So we could worsen this image. For example, we could add noise. And the model would additionally learn how to denoise this image. So this might be important for real life photographs where a camera has been used or an old smartphone that's not that good quality, so there might be noise in the image, so the model would learn to denoise. Additionally, we can add compression here because animes or images uploaded on the internet are often compressed, so it would learn to decompress too. And to make this more I'm a visual learner, I want to show a more concrete example of this. So what's happening is if we have a high resolution image, resize to factor 25%. So, or actually 50% if we do 2 times upscaling. And then, view image, let it run real quick. So I don't know how good you can see it, but this image is smaller here. It's half the size, as you can see here. Now, if we have a low resolution image to each high resolution image, this model would learn to, make it bigger. If we would like degradations, we could, additionally add noise. Let me zoom out a bit here. And then you can see that's extremely noisy, so we would, make smaller values. It's still a lot. Anyway, we could additionally add noise to this image, and we could also save the image with a lossy image file format with quality of 80. And so with this low resolution image to this, we would have it smaller with noise and with compression. So the model would learn to decompress, denoise, and upscale this image. Now the problem with doing it manually would be that our model could only would only learn compression quality 80 and monochrome Gaussian noise with the amount of 6. I'm hoping I'm saying those things correctly. So we won't do this by hand, but our model will actually do this on the fly. With a range. So we can then actually say while training, we want a range from 60 compression to 100, and then it will learn to handle that whole range. So this was meant for visualization for what will be going on. Now we have the data set, so the images, and you should also have a meta file in there where simply each image name is listed. Once we have that, we need a configuration file on how the model should actually be trained. And you will find this under options. There will be like 4 files around here for you, I believe. And I prepared a configuration that you can simply download. Now you don't need to know all of these things. Simply go to the ones where I actually made a comment. So you can change the name here, public one, just what your model will be named, will be called. Then you go to data root ground truth. Those are your HR images, and you change it to where you have extracted those images, right? So this will all be started from your code folder. So if I write datasets, it will go in here. If H2K, it will go in here. And this is where the images are. Now my meta file is in datasets, so I made datasets. So simply change these values to the correct position where your files are. And then you are already good to go. You don't need to change anything in here. I just want to show real quick. I changed some values. So I changed these ground truth sizes, made them smaller. And the batch size, I made it also smaller than what I used. This is because this will use memory space on your graphic cards, and I decreased these values for you to run into less problems when training your first model. Of course, the bigger those values are, the better your results will be, but you don't need to know exactly what all of this stuff does. Once you changed it, you simply go into the folder where you have your code structures. I have a little bit more folders, don't let that confuse you. And then you can open this in a terminal, and then you can paste or use a terminal command to actually run the training. So I'll paste it in here real quick and actually change it to the configuration I showed like this. Then you can simply press enter. Then it will output some configuration parameters, and you don't need to worry about this one because the file I will provide you with will not have this in it. So you simply will start, and the thing you will see here is more like this. So you can see it will say that it starts training from 0 iteration. So you just started training a model. So if you've followed all the steps till here, you actually don't need to do anything anymore in that sense. You can just simply run this command and then, let it train for a while until you've reached like 15,000 iteration, which will be enough for you to, use Chainer and already check the output if it's going to a direction you like. My models I've trained for around 24 hours at least, so it takes a while to train such a model, but you've already made all the steps, and now you only would need time, and you would have your own upscaling model if you've reached till here. And you can see here, good timing. It will output statements like this, where it will show the iteration number will go up and the epoch number will go up. So you can always see what the current state is of your training, because every 100 steps it will output such a message. When you reach 1000, then it will save it as a model checkpoint. So after 1000 steps, you would have a model file that you could use within Chainer. Wouldn't be any good since it's way too little iterations, but it will save it as a model file from these steps. You can see it in the configuration here when we are saving and when we are logging out. So I'm going to cancel it here, but you can just let it train. I'm just going to show you how it will look. Let me see. I have a lot of models I've been trying out and configurations I've been changing up. But what you will get is a folder like this with your model name that you defined, log files, and then within models, there will be files. You don't need to worry about the netd. Those are the discriminators. You will need the netg, the generators. And you just simply take the highest, iteration that you went up to, the netg file. And this is the model that you can then, use within Chainer. So I'm just going to show real quick. If we do, okay, I would only have needed the load model, but we can simply, drag and drop it in here. And this isn't the anime model, this is a real photograph model with 4x scale. But you can see, it's valid. It's a model that's valid. A compact model, meaning why I chose this architecture is it's, faster to train. It takes less resources to train, so it's simpler, and it's faster when upscaling, images, especially if we're talking about anime. If we actually want to upscale a whole clip, then we want a fast model. So here you can see it's 4 times because it's a different model. But this is how it will look like and what you will get out of it, these model files, which you can then use with Chainer to upscale images and see if you like the progress, the direction your model is going to or not. But that's all you need. Till here, you can train your own models now. Now, where would you go from here? What are things that we could still improve on? I will show in the options file I provided. What we could do is we could provide a pre-train. So in here you could put a path to a pre-train. A pre-train is simply an upscaling model that someone else already trained, and it will take this as a kickoff, as a starting point, and your training, you will get results way faster. So you could, if you want to, you can put in a pre-train in here. You need to make sure that it's the same architecture and the same, scaling factor that you used, which you define, up here. But I can provide, I believe, the link to these models as well. So if you want to, you can additionally use a pre-train. This could be any model that anybody trained, which is already going into the direction of the model you want to train. Something else you can do is you can try around with batch size. So the higher you set the batch size, as long as you're not running out of memory, otherwise come and change it and lower it again. But you can see I used value 12 here. What this will do is it will stabilize training. So in other words, your model will be better if this is higher, but it will take longer to train. If you actually want to, fast train, there is a method that you can try out as well. You can start with batch size 1, and then the iterations will go very fast. And then after a while, you can go with batch size 2, and then batch size 8, and then batch size 4 and 8. and just, go as high as you can, and training will be way faster and the results will be similar as if you would have used a high batch size from the beginning. Something else you can do is also you can always play around with the config settings. If you go to Real-ESRGAN, you can actually have a look at their options, what they have used, so you can see they use different things than I did. They used noise and Gaussian noise, things that I deactivated for the anime model to get more details in there, because I believed that I would only need compression. So you can see this up here. I have 0 values. But something else is you could also, it's not needed. There is a validation setting. So you could put in images from the internet, different images, not images that you have used to train it, but images that you would like to, have upscaled with your model eventually, what it's used for. And if you do something like this, let me show you a config real quick. Yeah, maybe I used it in here. Yeah, you can see every 2,500 steps I did a validation with PSNR metric and SSM metric, and I defined those up here. What will happen is you will see in the visualization, it will create the folder for each of your files, and then every step that you defined there, it will upscale this image, save the output, and in the log files, it will actually give you the matrix. So what this is useful for is you can always see, does this value get better? Is my model still improving or not? Because at one point, your model will be, fully trained. It won't increase in quality in that sense. So this is something neat you can do to have a metric pop up, but you don't need this, it's not required. But it's something I used at the beginning, If I show you my batch points real quick, you can see I started with batch size 1 and did so long until I reached the highest SSM. Then I changed to a higher and actually continued training from that checkpoint and then again from that checkpoint and then, up till batch size 9 for this example here. So that's also with a metric, but that's with the variable batch size method I showed before. I think that's it right now for locally training models. You can, go with a different architecture if you want. You can go with different settings if you want, play around different data set downloaded from here to train whatever you would like. Now this is all local training. Like I said, you can also use, online resources. Something I've used is Kaggle or Kaggle. I don't know how to say it, but what you get here is every week you get 30 hours of GPU time you can use to train a model. And the GPU here has more RAM than mine. Mine locally has like 8 GB RAM. I believe this one has 12 GB RAM. So I can increase the batch size higher before running into errors. And in here, I simply created a notebook. This is actually this model here, so that's a good show. So what I did is I simply inputted all the commands, what we did locally before in here. So installing all the dependencies, an additional command because sometimes I ran into errors. And after that, you can see I added training files. I downloaded or uploaded the config file from my Google Drive, and then I simply started the training command. And yeah, and then it was training, and we can see the output in here, or we could see it if we would go, to a version, view full version. So you can see the training logs here too, and the output in here as well in experiments is where the model shows up, and then you can see all the model files in here, which I then simply download, the NetG 39,000 iterations, and then I can simply download it. Now, the advantage here is, like I said, it's a more powerful GPU I can use, and I also don't need to run my local PC like I would normally train overnight because, electricity prices are cheaper here where I live during the night. So I would leave, my computer running during the night, and then after I woke up, check the results real quick, and then let it run the next night. In here, you can just leave a session running for 12 hours. So you simply start it and then, close the browser, shut down your computer, and it will train for 12 hours, uh, this model. And then, you can let it train for another 12. And then at one point, you will run out of your GPU time, which will reset for me each Saturday. It will show here when it resets, but every week it will reset to give you another 30 hours. That's something else. You can also use Google Colab. But what I've run into here is if I let it train, the window needs to stay open because I would, have more tabs and work in other tabs and then come back. And since Colab needs to be an interactive session, it would have stopped the console script. I would have, added to Colab to think it's an active user and not just somebody training it. So yeah, with Google Colab, I didn't like it that much, so I used Kaggle where I can just close it all and just shut down the computer and it will train. Something else I have used is also AirPod. No, that's not right. Runpod. Nice. Runpod. So this is a service which I can use as well. Well, seems like I don't have it stored. But the thing is, this service here actually costs. So Kaggle is for free, but only 30 hours GPU. And this one we can use as well. And you can see, is there GPU distance? Yes. So that's secure cloud, the community cloud pricing. So you can see if you let it run on one of these GPUs, you can choose one of these GPU instances. So let's take 16 gigabyte is already a lot. So this one will cost me $0.18 per hour when letting it run. And I can use a service like this if I still need, still have higher resource requirements to, for example, 16 because Kaggle doesn't give me that much and my local system doesn't give me that much. So this is a service I also used in the past if I wanted to know, up the resources I need because, I was running out of RAM with batch sizes and ground truth sizes and everything. So yeah, those are all the options I wanted to show you, and yeah, hope it was interesting. Hope you learned a little bit. And that's all you need to actually train your own model. And if you have questions, go into the Discord of Enhance Everything, and then there is a trainer channel, and it's the channel we use, where we discuss training stuff and configs. You can see I was very active lately, training all different models, and others playing around with configs, and others have been active here as well. See training their models, which they then finally released in the model releases. You can see here. So yeah, that's all you need. You can train your own models now for upscaling, anime or real life photographs or game textures or, whatever you would like depending on your dataset and your configuration. So yeah, thank you for watching.